Hey guys, Mr. Murphy here with another video lesson. This one is on something called the Chord Chord product theorem. So, when you have two chords that cross in a circle, what I want to show you here is a way to find the lengths of missing segments of those chords. So for example, number one, we're going to solve for this X segment, which is just this little part right here. I'm going to give you a theorem to allow you to do that pretty easily. Okay, so up here, I have kind of drawn a circle with two chords in it. So let's go ahead and I'm going to color code them. We've got a green, and I'm going to color the other one blue. Cool. So for this part, you're going to hear me call it the blue chord and the green chord. Okay, now let's label the parts of the green chord A for the length of the longer part, and B for the length of the shorter part. And then for the longer chord, or for the blue chord rather, let's call this part C, and then the longer part of the blue chord is D. So we have AB and then CD. Okay? So, when you have chords that cross in circles like this, they cross in a way that's sort of proportional. So the relationship to find any of these lengths can be expressed like this. A times B equals C times D. C times D. Cool. In other words, if I take both parts of one chord and multiply them, that product, we call it, is the same as the product of the parts of the other two chords. So A times B is equal to C times D. So both the green parts multiplied together equals whatever both the blue parts multiplied together are. Now, this is pretty fun. This is kind of like a test of, do you know your times tables? Especially for problems as simple as number one. So let's take a look at number one. We're solving for X. Just like before, I'm going to color code a blue chord and then a green chord. And then we're going to solve accordingly. Alright, so just like up here with these two chords, I need to take both parts of one chord and multiply them. Then I'm going to set that equal to both parts of the other chord multiplied together. So let's start with the green chord. The green chord, I have both parts. That's going to be 6 times 6. Then on the other side, we're going to multiply both parts of the blue chord. That's going to be X times 9. Cool. Now, watch how easy this is. 6 times 6 you already know. That's going to be 36. And then X times 9, we're just going to leave it as 9x. Cool. And then to solve for x, we just got to get rid of this 9. Since they're multiplying, divide. Cool. So in other words, x is equal to 4. Now, I mentioned times tables earlier because if you're pretty good at mental math multiplying and mental math dividing, you can kind of do these problems mental math. For instance, if I look at 6 times 6 and I know that that gives me 36, I just have to think of myself, what number would go here that multiplies by 9 to give me 36? And that would have to be 4. Awesome. This is probably the most basic example of chord-chord product theorem. In example number 2, let's put it together to write an equation and solve for x. So, same way as before, let's mark the two different chords. One blue, one green. If I set it up the same way as before, A times B equals C times D. I'm going to take the green chord, that's going to be 10 times 4x plus 2. And I write it in parentheses like that because I want to make sure I multiply everything. then the blue chord, so C times D. This case, that's going to be 9 times 5x. Okay, so this one is a little bit more involved, but you guys have seen plenty of equations like this. So we know that whenever we have that number multiplying by a set of parentheses like this, we have to distribute. So 10 times 4 is 40x. 10 times 2 would be plus 20. On the other side, we are also distributing, but that's a little bit easier. 9 times 5 is going to give you 45x. And there's our equation. 40x plus 20 equals 45x. Now, I'm going to get my like terms together. So draw my line. 40x plus 20 can't be added. There's an x on the other side. So that means I want to get this 40x over here. So take away 40, take away 40. That leaves me with 20. 45 minus 40 is going to give me 5x. And then just divide by 5. So divide by 5, divide by 5. X is equal to 4. Hey, that's a coincidence. But yes, in this case, we should get x equals 4. If I plug that back in, we should see that the chords obey this relationship. But when you're setting equations up using chord-chord product theorem, make sure whatever b is, write it in parentheses. And if b is an entire something like 4x plus 2, make sure you write it like that, so that you know to distribute. Okay, we're going to do one more, very similar to this one, where we have to build an equation and solve. So, something a little bit different is going to happen here, though. That's why I want to make sure I show you this one, too. So, we are going to find the length of SH, which is this part here, the 5x. But, of course, we know this means that we're going to have to solve for x first. So, again, I'm going to do my blue chord and my green chord, so that we can set up chord-chord product theorem. A times B equals C times D. Cool. So I'm going to do A times B, the green chord, just like this, up here. So 15 times 16. And then I'm going to set that equal to C times D for the blue chord. In this case, that would be 12x times 5x. All right. Now I'm going to go ahead and do 15 times 16. That gives me 240. So 240. And then on this side, I'm going to do 12x times 5x. Now be careful here. 12 times 5, no problem. That's 60. But make sure you also are thinking about x times x. That gives us x squared. So that changes how we solve the problem a little bit when you run into that x squared. But let's go ahead and proceed. This is nothing too crazy. All right. So we want to solve for that x, right? Which means we have to get rid of both the 60 and the squared. Now the first thing I'm going to get rid of is I'm going to divide by that 60. That cancels that out, leaving me with x squared. On this side, 240 divided by 60. I notice both of those have zeros, so get rid of the zeros. 24 divided by 6 is just 4. Okay. And then with this problem, since we did have that x squared, we have the extra step where we need to take that x squared and turn it into just x. Now, of course, how do we do that? By taking the square root. And if I take the square root on this side, then I have to take the square root over here also. So instead of being equal to 4, x is going to be equal to the square root of 4, which is 2. Okay. Cool. So when you have variables on the same chord, you do wind up with that variable squared, but just make sure you take the square root at the end. Shouldn't be a problem. Now, real quick, we wanted to find SH, which was this 5x. So just plug that in. 5 times 2 tells us that SH equals 10. All right. Cool. So when you're doing chord product problems, some of them will be as simple as this, where you have to multiply two numbers, divide by a third number, and you can often mental math those. Some of them will be like these two, where you have to build those equations. Just make sure you are setting it up the same way, where it's the two parts of one chord equal to two parts of the other chord multiplied together. And make sure you're writing things in parentheses, and I have no doubt that you will do just fine with these. Alright guys, thanks for watching. Hope this helped. I'll see you on the next video.